included, obviously it starts from education, so you need to show with a certificate that you have an engineering degree, and it cannot be from anywhere. It should be something which is recognized and approved, and this should also include having some training, hands-on experience, where you go to the site and see things for yourself. Then to make your value more, you should also look for more certification, not just the certificate of bachelor's, but something more as well. Certificates for communication, for softwares, and so on and so forth. Networking is very important, and just to share something with you, the first job I had was through networking. Okay, and it was like a bizarre thing. Like nobody knew where this job is. Somebody told me, one of my teachers told me, that there's a job, go there and apply. Okay, and I asked him, where is it? He said, oh, I don't know. I said, who told you? He said, one of my friends. So I said, why did you call? Because at that time we had those phones, keypad on these with the map. You search on the map and it tells you to go right to it. Not like this. Okay, so we had the old phones, and you have to you should know where to go. Something you should all know in life, where you are going. Okay. At that time it was more important. The map will not tell you where you are going. Okay. There was no map. Okay. So I asked him, why don't you call your friend and ask him where should I go? He said even he doesn't know where you have to go. Okay. He just gave me the name of the company. Okay. And look for it and just go. Okay. So I went there and I worked there. During my interview, during my working there, I did not meet any person I know or my teachers know there. Okay. So I still don't remember I got that job. Okay. So that was my first job. That was my first job. And this is my the last, right? Up till now. The last one. Okay. And even this one is through networking. Okay. This one is also through networking. Okay. So from the first to the last. And it's not only you can say no, he was applying in universities. No. The first job was with a contractor. Okay. The first job was with a contractor. Okay. So and it was in Pakistan. The last job in university in Bahrain. You can see how different the things are. Huh? Contractor in Pakistan, university in Bahrain, but the same rule applies, right? You need networking. Okay? And I told you the last lecture I told you networking means that you have to get in touch and get involved with these people. Having a contact in the phone is not called networking. Having a friends list of 1,000 people is not called networking until you connect with them regularly. And you know what they are doing and they know what you are doing. Okay, this is called networking. Clear? Okay. Some other things which we discussed. Okay, you should adopt for a specialization. It will increase your value. You may get a higher pay. You should continue your education throughout your career as well. Okay, and you should look for career advancement opportunities, things which will increase your level. Okay, which will uplift you in your standing. Okay, so you are an engineer, now you are a manager or a director. Okay, or the owner of the company. Okay, or the captain of the football team, right? We will see. Just remember it, right? Okay, clear? So these are the things which we discussed. Now we move on to the second thing. Okay, about what are the different types of tasks which we have to do as an engineer during the career, during the profession. The first thing we need to keep in mind that whatever we are doing it according to the science, the principles of science and mathematics. Okay, this is our core. Our core is what? The knowledge of science and mathematics. Okay, this is the core. And what is our job? To apply it. Okay, the core is these two things. and the job is to apply it. Clear? Okay. So some of you think that I can run the software and that's enough. It's not enough. Okay. When you will go in the career, you will find many people who can run the software better than you. Okay, who can run the software better than you, but they are not engineers. Okay, and then you are liable. This is your responsibility. Even if they are using the software, I mentioned it today in the AutoCAD lecture as well, that you normally have a draftsman who will prepare the drawing, but your name and your stamp goes on it. Okay, clear? It's like the doctor and the pharmacist. Okay, you take the medicine from who? From the pharmacy, right? But who is responsible? The doctor. Okay, the pharmacist can say, okay, I did what the doctor told me. Okay, but the doctor cannot say, I did what the pharmacist told me, or I did what the patient was telling me. Okay, so the knowledge is your core, and you need to know how to apply it. Okay, in how many ways we can apply it? These are the things. This is what we are listing down now. Okay, you can apply your knowledge to design something new, design maybe a new structure, design a new product, design a new system. Okay, so you are designing something which is not existing. Okay, a road, a bridge, a building. Okay, something which is not there. Okay, it could be a software as well. It could be a new computer system. It could be a new device, a new laptop, a new phone. All these come under design. Okay. So the fun thing is design, and when you are looking at the design, we have already mentioned these things, right? Okay, the cost, the safety, the reliability. Anything new here in this list? You have to consider factors. This. Any new factor here? Environmental impact. We mentioned it. We mentioned it with a different name. What was that? Environmental impact was not an environmental impact, but there was another term. What was the term? Anybody? We call it sustainability. Okay, so sustainability deals with environmental impact. Okay, so you have to keep in mind. Any other thing which is new here? Functionality. Okay, the new thing is functionality. And again, something which we mentioned earlier, but with a different term, that it should fit the purpose. Functionality means it should fit the purpose. So you have two types of bridges. I keep on giving this example. The one which is for pedestrians, okay, people, and the one which is for trucks and buses and cars. Okay, so their design is not the same, right? Okay, so somebody may come and say that, see, I'm designing a bridge which will only cost you 40% of the total cost. So it's very cheap. And it's safe, and so on and so forth. It has no environmental impact and everything. Okay. But I asked him to build a bridge or to design a bridge for the cars, and he is giving me the design of the bridge for bicycles. So whatever he's saying is correct. The cost is very low. It is safe. It is reliable. It has less environmental impact, but it does not fill the purpose. Okay. So the first thing you need to keep in mind. That's why you can see it's written, it's mentioned as the first thing is functionality. Okay, whatever you're designing, there is a purpose behind that. Okay, and your design should fill the purpose. Okay, you may have seen, I don't know if it's allowed here now, but in Pakistan happens. There are schools, small schools. I believe in pre-nursery they do this. They have this preschools, right? Okay, so some of them are in villas. There's a villa and then they get it approved for a preschool. Because there are very few people, there are very few kids and so on. Okay, so they get it approved. But there you will find many times that the classroom is this big, like maybe quarter of this. If you put like 3 chairs, it looks full. Okay, why? Because it was not built for a classroom. Okay, I studied in like I said, in Pakistan it happens to at a higher level as well. So I studied in a classroom. There was a pillar in the middle of the room. It was this big. Okay, but it was a nice place to sleep. take the chair on the other side of the pillar and relax, no problem. Nobody can see it. Okay, so you sleep and eat and whatever. Okay, just have to keep in mind that they do not lock you inside. Okay, that's it. So functionality. Okay, I was talking about functionality. That room with that pillar is not built for a classroom. Clear? Okay. Then we have to we do the analysis. Okay. For analysis is performed on data. Okay. So whatever data you have, you take that data and you do some analysis. Okay. Analysis means that you use that data to calculate some other values. Okay. And you already know some of these values. Okay. For example, if I give you like 10 numbers. Okay. And I say do some analysis on these numbers. What can you do with these 10 numbers? What are the things you can get? Yes. Average. You can calculate average, right? So calculating average is analysis of the data. Calculating an average is analysis of the data. Okay. If I give you temperature data for 1 month, so you can calculate an average, right? Average for the month. And what else can you see? What else can you analyze from this data? I'm saying temperature, right? Variance. Huh? Variance. Variance, okay, yes. Huh? Mode, okay, fine, yes. Maximum, minimum, yes. Anything else? Now I said temperature for a reason. It's temperature data, right? So what else can you see? All these are values, right? All what you have mentioned are values. Mode, mean, values, all these are values. But there's something else which you do not see in a value, but you see in the data. What is that? Change of temperature. So some analysis can be graphical as well. So I can plot the data day-wise and I can see the temperature is going up and down. Okay, clear? Okay, so just to give you an idea about what we mean by analysis. So first of all, to do the analysis, you need the data. To do the analysis, you need the data. There is no data, there is no analysis without data. The analysis can be numerical, so you calculate some values. But the analysis can be graphical, where you plot the data and see. And then the graphs can be of different types as well. The graphs can be of different types as well. The one which I mentioned with the temperature, you will just plot the value, right? And you will see values are going up or down, right? Okay. Clear or not? But let's say the data is about how many boys and girls are in the class. Then what type of graph I will use? I cannot use this one, right? What type of graph I will use? Anybody? Huh? What is that? What will it show? And what will it show? You are right. What? Yes. Okay. So you may go for a bar chart then, which will show you either the number of boys are high or the number of girls are high. Okay. Or you may show you may go for a pie chart, which shows you the percentage and so on. Okay. So this all comes under analysis, but it starts from data. It starts from data. And the analysis can be numerical or graphical. Okay. And the type of analysis will change according to the data. Like I give the example, if there are just 10 random values, mean could be enough. But if it's temperature over each day, then you may go for a graph. Okay. Or if there are number of one category and number of another category, you may go for a bar chart. You may go for a percentage and so on. Okay. Okay. Obviously nowadays we rely on softwares and computers and the cloud-based system for our analysis. Okay. But as I mentioned earlier, somebody cannot claim that I am a very good engineer because I can use this software. Okay, and I have many examples. Now, sometimes I get the reports and research papers for reviewing. Okay, and I get it from people who are from computers, for example. Okay, so they know how to use the software. They do the whole software themselves. They design a new software just for this sake. A new software which works brilliantly. Okay, but they don't know what data they are putting in. Okay, boys and girls. So in the computer they put boys 1 and girls 2. It's not like this. Okay? So the thing you have to keep in mind that you decide as an engineer because you have the knowledge. You have to go back to the first step, which is the knowledge. Okay? And why we do the analysis? What is the purpose of doing the analysis? Analysis mainly, but there could be others as well. Mainly for performance evaluation and feasibility of the design. Evaluating the performance of something or looking at the feasibility of the design. Okay? Now I told you, when we are designing, are we designing for something we have or something we will have in future? What do we design? Something we already have or something which will come in the future? I asked you to design a building. Is the building already there or it will come in the future? In the future, right? Okay. So, feasibility of design, you are looking for something which will happen in the future. So, how it will react? What are the effects of your design in future? So, this is something which is related to the future. Performance. Okay. So, if I go to my laptop, okay, and I have all your names and I start putting your grades there. Before the quiz, before the test, before the final exam, I start putting your grades there. Am I evaluating your performance? No, right? Okay, but I can do that. I have some idea. By the after second month, I start getting the idea. Okay, especially with your case, with A's and B's, it's very easy. In our case, it was like numbers, numbers. So, what do you think? Yeah. I will do the performance evaluation when it will happen, right? When you will do something, the quiz and the exam. Okay. So performance evaluation is current, and feasibility is future. So analysis can be for something which is happening right now, and this can be something which will happen in the future. Okay. If you are doing it for future, then we call it simulation, because it's not there, right? I cannot just go and see. Can I do that? I cannot, right? Okay. So I have to simulate what will happen when this building is constructed in the future. Okay. So something which is done for the future, a model, a result which is generated for the future is called as simulation. Okay. Result which is generated for future events is called as simulation. Okay, for sure. We can do simulation for present as well, no problem. Okay, we can do simulation for present as well. But for future, there is no other way, right? For present, you can tell me, okay, I simulated or maybe I observed. Both options are available, right? If I ask you how many vehicles are on the road, we can do simulation and we can go and check, count. Because the road is already there, the vehicle is already coming. Okay? But for future, there is no other option. Clear? Okay, so future is, simulation is when you are trying to replicate. Simulation means you try to replicate or duplicate something real in virtual environment. Okay, so something may happen in future, but it will be real, right? The building will be real, the road will be real. Okay, and then I try to replicate it in a virtual environment, in the software, in the app, and so on. This is called simulation. For future, this is the only thing we can do. We have to replicate it in digital environment. We don't have the physical object. Okay? But for present, it can be both. You can observe it or you can simulate it. Okay? But even if you simulate it, I said what? Simulation is what? What is simulation? Anyone? What did I just say? Simulation is what?
To anticipate something in the future. To anticipate something in the future.
No. I said for feasibility studies we have to do simulation, right? Okay, but we can do it for present as well. But what are we doing in simulation? What are we doing in simulation? We are replicating something which is real. Okay, so you cannot just assume anything. That's what I wanted to say. Okay, simulation is virtual, but it's a replication of real. Okay, so it's like a picture. So your picture should look like you, right? Your picture should look like real you. Huh? Very hard to believe in this these days. Right? Everybody looks nice on Instagram. Right? And look at these faces. MashaAllah, no problem. I have some of these faces that you are like, I see your ID cards and I'm shocked. Like the person there and the ID card is there. Who is that? Huh? I came to the conclusion those pictures are taken when you come out from the school, right? They then put them on your ID card, right? You don't know what is the real world. Huh? Okay. Simulation is the picture of the real something real, which is in digital, and it should look like real and it should not be assumptions. Okay. Testing. Okay. Testing and inspection. You can include inspection here as well. So something which is happening, you test its performance. Okay. You test it is up to the standard or not. Testing is done to check the level of conformance of something to the standard, to the law, to the rules. Okay. So I can check, for example, this is the column we have. Okay. This column is made up of concrete. When an engineer designed this column, he said the strength of concrete should be this much. Okay. So I need to test it to make sure that the actual strength is this much or not. Clear? Okay. So, and inspection, it could be inspection as well. There are some things you don't need to go and test in the lab. You can just see them visually. Okay. So you have already taken the course on surveying, right? All of you have taken surveying, right? How was it? Yes. How was surveying? How was it?
Worst course.
Worst course. I thought tell the book of the passion.
Why?
This is why I will ask them. I need to tell them this is what the students think. Your name is Zahra, right? Tell the name as well. Anyways, just joking. So, surveying is what? You do surveying in lab? Like you did, okay, fine. But we don't do it. Like in real project, it happens in the field. Okay, so you have your level and theodolite and your staff and everything. Okay, who was doing it? Somebody was doing it. In the previous, like on Wednesday, somebody was doing it in the morning when I came. One of you, I forgot. Anyways, so in surveying, you are collecting, you are inspecting. Okay, so you take your level and your theodolite and your staff and you see the things are according to the plan or not. This is why we do the surveying. Okay, so surveying is also part of testing. Okay, testing and inspection. You visually see the column is up to the correct height and correct width and length and so on and so forth. Okay, so testing can be done in the lab and testing can be done visually as well. Then we call it inspection. Okay, and when you are doing it, the purpose is to check the real with the standard. The purpose of testing and inspection is to check the real in conformity to the standard. Then we do the implementation as well. So we implement the construction, we implement the system, we implement the product. Okay, if you design a new machinery, then you implement it, assemble it. Okay, so all this comes under implementation. Okay, so implementation is now you are going to build the thing now which you have designed. Okay, the actual thing. Okay, the building, the roof, the bridge, and so on and so forth. Okay, and implementation also involves working with other professionals. Okay, everybody who is working on the construction project will not be a civil engineer. Some of them are electrical engineers, mechanical engineers. Some of them are accountants. Some of them are software engineers. Okay, I'm going to give you the example that I know somebody who is an IT engineer, but she worked in a construction firm for like 4 or 5 years. So obviously those people were not all IT engineers, but they were working together, right? So in implementation, then you see the broader aspect of the field, that you see many people who are from other fields. Okay, they may not understand what we are saying. Okay, I shared something which just recently happened. In civil engineering, And even in architecture, they use the term G plus 1, G plus 2. You know that? What does it mean? G plus 1 means what? Anybody? It's used for building. G plus 1, G plus 2. You don't know, right? Okay. What?
GPS.
No, G plus, not GPS. See, he taught you well. Okay. G plus 1 means ground plus 1 and ground plus 2. So, okay. So obviously you don't know it yet, but later on, I hope, but you will remember. Okay. I'm telling you. G plus 1 means ground plus 1. G plus 2 means ground plus 2 and so on. Okay. So those people who are reading the report, I mentioned somewhere, we have a ground plus 2 building. Those people are supposed to be like, they are MS and PhD and so on, who are reading the report. But they are not from civil engineering. So they wrote the comment, what is G plus 2? We don't understand. Okay. So their education level is very high. Okay. Their experience is more than me. But they are not from my field. So now I have to deal with them. I have to make them understand what I am saying. Okay? I have to make them understand what I am saying. Okay? Same thing happens with accountants and so on and so forth. Okay, this is continuation. Maintenance is also part of what the engineers do. The maintenance of the asset, which is designed and constructed, is also part of the work of the civil engineers or the engineers. Okay, so I have friends who are working in hospitals and banks and these industries. Okay, so obviously a bank does not construct new buildings every week. Okay, or a bank does not do that. Okay, but you will find there that engineers are working and their main job is maintenance. Okay, so they see the maintenance needs. Obviously, maybe after 3, 4, 5 years, they may have to do major maintenance or a big construction work as well. It can happen. Okay, but this is very rare. Okay, most of the times they are involved in maintenance work. Okay, so they look at how the buildings and the assets are working and when they will need maintenance, and they can do it before it fails and so on. Okay, so the maintenance is done to make sure the operation of the facility is going smoothly without any problems, without any failures. Okay, so the main purpose of maintenance is to ensure the smooth operation of your facility. It can be a building, it can be a road, it can be a bridge, it can be a water system and so on. Okay, engineers, okay, also do research as well. Okay, research means what? What do you research? Research means what? Information. So you Google it's research, right? And you Google something, it's research? Yes? For you it is, right? You can't have it, see? We did research. I did my research. Like I spent 10 seconds on typing, and I spent 2 seconds in reading. I did my research, right? Okay. Research, in Arabic they call it what? Tahqiq, right? Tahqiq. Okay? Bahas, yes. Bahas also, yes. There are some terms which are common in Urdu and Arabic, so yes, I understand. Okay, so bahas, right? There is another meaning of bahas in Urdu as well. In Urdu it means argument. When you are doing bahas, it means you are arguing with someone. Okay, so this is what we call as research. Okay, if you are finding out something, it's not research. Finding out something which is already there is not research. Okay, so if I ask you what is the height of this screen, now you don't know it yet, but you come and you bring your scale and you find out this is not research, this is observation. Okay, I give you a book and I tell you what are the chapters in the book. Now you don't know it yet, so you will read. Okay, this is not research. Okay, research is if I ask you, okay, this is the book, somebody wrote it. Now find out the mistakes in the book and prove that these are the mistakes. Okay, somebody may come and say, no, your the spelling of "does" is not correct. Who said so? This is how I write it. Okay, but now then you go and bring something which will prove this is incorrect. Okay, This is correct, okay, by the way. So this is called research. Okay, when you analyze the information critically, okay, you are looking for a fault in easy way, in easy terms. Okay, you are looking for a fault. Okay, and when you find it, then you see why is this the fault and what can I do to correct it. This is research. Okay, so reading and searching and measuring is not research. Okay, when you read something, when you search something, it's not research. Okay, when you look at something and you apply your mind to it, what are the mistakes here, how can I correct them, if I say this is a mistake, why I am saying it is a mistake, so you do it with proofs. Okay, this is called research. So you analyze information critically, try to find ways to improve it, and with proof, everything with evidence. This is called as research. Okay, so obviously engineers are trying to do research to improve the solutions which we are providing to the society. The aim of our research is to improve the life of the people. Okay, so how can make the buildings better, the roads better, the infrastructure better, and so on. Okay, this is our aim. Scientists also do research, by the way. Scientists also do research, something which we covered last time in the previous slides. Scientists also do research, but their aim is not the benefit. Their aim is to just gain knowledge. Okay, they are also following the same method. Project management, managing the projects. Okay, so again, this is something where you have to get involved with so many people. Okay, in a project, there are lots of people involved, especially in construction projects. The workforce is usually very large, and they come together for a very small time. No project is like for 50 years. Okay, if it is, that means you are doing something wrong. Okay, you will die before the project finishes. So, management includes so many things: planning, budgeting, scheduling, timetable. Scheduling means timetable. Coordinating with people and activities. What will happen first and what will happen next? Can I do them parallel? Can I make a wall here and a wall here parallel? Okay, or should I do it one by one? This is called coordination. Okay, in the end, the aim of project manager is that projects are completed first of all. There are lots of projects. You will find many buildings and many villas, and they remain incomplete. Okay, now how long have you been hearing about metro? How many years? Anyone? The metro bus service and the metro train. How many years? Many years, right? Huh? Right? And there is another causeway as well. They will build another causeway, right? Okay. I've been hearing about it as well. Many projects did not complete. Inshallah, it will complete. Okay. Let's have high hope. Before your kids come here, inshallah, it will complete. Okay. So project completed first of all in time and in budget. Okay. Many projects do not get completed. Many projects get completed but with delay. Many projects get completed but with extra cost. Okay, so the responsibility of the project manager is to make sure that this does not happen. Okay. The last thing is, which I already mentioned, collaboration. It is part of management, maintenance, and so many other things. Okay, so I've already mentioned it many times. Some of the specializations which are written here. You collaborate with architects, which are living in another world, like they don't understand it. They are from another planet. Okay, where everything is done. Okay, like from Krypton or something. Okay. Then we have contractors. Okay, who will not understand anything. Like, they know how to do it, but they don't know how to say it. Okay. And then we have scientists as well for no reason. They are also involved. Okay. So you have to collaborate with all of them. Clear? Okay. Any questions?